You get it right from the function, the h and the k, you get the vertex. You need the vertex here, and then you have to solve for the y-intercept. You have to solve for it, and how you do it is, since the y-intercept, x is always 0, then you're going to substitute 0 into the function, and then you're going to solve for y, and you find the y-intercept. This one she should know already from transformations, how it opens up or down. If a is positive, a is the number that goes in the front. Sometimes it's an invisible 1. And then that same a tells you if the vertex is going to open up, the vertex is at the lowest point, and since it's the lowest point, it's the minimum. If it's the highest point on the vertex, because on the parabola, because the vertex is at the top, the parabola opens down, then it's called the maximum point because it's the highest point. The line of symmetry, I call it LOS. It's the line where the parabola is divided in half. So it's an axis of symmetry. Sometimes you hear that word out there, axis of symmetry, line of symmetry. And again, you get this just from the equation, just by looking at this part up here where h is. That's where you're going to get the line of symmetry. So you already know which side it's going to go. The point of reflection, you find it if you can. Sometimes on the graphs you can graph the y-intercept, and then sometimes you can't. If you can graph it on the graphs that I give you, if you can graph the y-intercept, like in the front over here, where you actually can find the y-intercept, then if you can graph it, you count to see how far it is to the line of symmetry, and then you count that same distance on the other side to find that point of reflection. That's what I'm talking about when I say point of reflection. If you can't graph it, like right here, where you don't have a y-intercept, the parabola goes down and you don't know how far it's going, you know it's going to negative 15 because you solved it, but you can't see it, then don't worry about finding it. You don't have to worry about finding it. Okay? So you're only going to find the point of reflection if you can graph the y-intercept. You can always find the y-intercept, but you can't always graph it. And for the CP students, I asked them, if you can graph it, then find it. If you can't graph it, don't worry about it. So basically, that's about it as far as this is concerned. The notes are pretty straightforward, and if you look at the answers for the ones that I did, it follows the notes pretty straightforward after that. Okay. After you do the vertex form, you're going to do the standard form. In the standard form, on the equations, you're going to notice there's no parentheses on this one. So you're going to be looking at the numbers in front of the x squared, the x term, and then your constant. If your constant's missing, then it's a 0. If anything is missing, it's a 0. But you're always looking at these numbers, the a, the b, and the c, in your standard form. The a is just like from the beginning with transformations, just like vertex form. If it opens up, opens down, then that tells you the vertex is a maximum or a minimum. This little number right here tells you all of that. The c is in this form of the equation. You are given the y-intercept. This is your y-intercept at 0, whatever that number is, c. But you have to now solve for the vertex. And in order to solve for the vertex, you're going to use this little formula. X is equal to negative b over 2a. And you're going to look for your b on your function and the a from the function. You plug it in to get x. Whatever you get for x, that is the first part of your vertex. Then you take your x, whatever you get, and you're going to plug it into the equation to find y. And once you plug it in, you do all the work, dot, 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 and then you get y. So now you have x and y, you found your vertex. And if you look at the examples that I gave you, you look for a, b, and c, like I told you. Look at the a, it'll tell you if it opens up, minimum, all that. Look at c, that's your y-intercept. And then you're going to start solving. So how do you find it? You're going to follow the little formula. Negative b over 2a. And, substitute your b and your a, solve for it. Once you find x, then substitute it into the function right here and solve for y. And that's your vertex. And if you can graph the y-intercept like before, if you can graph the y-intercept, which sometimes you can, then you should be able to tell me the point of reflection. If you can't graph it, don't worry about it.